tricing's design and materials are pushed to the limit. In this case, a delicate balance that requires expertise and courage. The miraculous inner glass layer remains stable under tremendous pressure. The crew moved on, drive the submersible deep into the trench. The depth gauge finally recorded an amazing foot, confirming that they have reached the deepest point in the world's oceans. This measurement is consistent with sonar data and previous estimates, indicates that the trench depth could be closer to 7 miles. During exploration at the bottom of the trench, Walsh and Packard observed a plaquefish. This rare sight further confirms their location in the deepest part of the trench. They also managed to take a selfie. This iconic photo symbolizes their achievements. Although their venting intentions are significant, but the visibility at the bottom of the trench is affected. The agitated sediment reduced the clarity of their observations, makes it difficult to fully document the unique characteristics of the trench. Despite this, the mission was a groundbreaking success, provides valuable data, and demonstrate the human potential to explore extreme depths. This dive tries to demonstrate the remarkable capabilities of early deep-sea technology and the courage of the crew, while trusting Stiff to make history. In the 1950s and 1960s, geologists, including Princeton University's Harry Hess, mapping the ocean floor using sonar technology. These efforts culminated in the discovery of the Mariana Trench. It's part of a vast network of underwater canyons. The mapping process also revealed the Eastern Pacific Ridge. This is one that runs parallel to the Mariana Trench, a vast underwater mountain range across the Pacific Ocean. This finding suggests that trenches and ridges, there is a geological connection between them, provides clues to understand the formation process of these underwater features. Cold War, earthquake monitoring technology has made significant progress. The United States has installed an underground monitoring network, used to track atomic bomb tests. These instruments are also good at detecting natural earthquakes, provides crucial data on the Earth's geological activities. By mapping the location of earthquakes, scientists have observed that seismic activity is concentrated in the ocean, ridges and trenches. This model could help revolutionize our understanding of Earth's geological processes. The data collected from these size monitors provides detailed insights into plate tectonics and seismic dynamics, reinventing the field of geology. One of the most remarkable discoveries of this period was the recognition that the Earth's surface was divided into moving plates. These plates are constantly moving, cross each other. Occasionally collisions occur. This triggers earthquakes and forms geological features such as trenches and ridges. The Eastern Pacific Ridge and the Mariana Trench are important features of Pacific plate movement. To understand the interactions between these plates, it is essential for understanding geological phenomena and the underlying processes that shape our planet. Trace. The results of this dive combined geological and seismic data, greatly improved our understanding of the structure of the Earth. The formation of the Mariana Trench and the dynamics of plate tectonics became clearer, provides invaluable information on Earth's geological processes. People better understand the connection between underwater canyons and mountains. This reveals the processes behind earthquakes and volcanic activity. These discoveries advanced oceanography and geology, giving us a more comprehensive understanding of Earth's deep-sea environment. A deeper understanding of the Earth's structure lays the foundation for further exploration. In particular, The exploration and mapping of the Mariana Trench and the Eastern Pacific Ridge benefit from these advancements, providing new insights into these geological wonders. Exploration and mapping of the Mariana Trench and the Eastern Pacific Ridge. In the exploration and mapping of the Mariana Trench and the Eastern Pacific Ridge, some key developments changed our understanding of these geological wonders. As technology advances and innovations explore the emergence of technologies, attention to these underwater features is starting to get serious. A milestone in this expedition was the historic deployment of the submarine Trieste in 1960. Trice's good submarines can withstand extreme sea pressure, set a depth record for Challenger Abyss. This is the deepest known point in the Mariana Trench. This dive was not just an engineering feat. It was a major scientific endeavor. The mission provided important data about the depth of the trench and its surrounding environment. During this dive, the terrace used sonar technology to map the nearby Eastern Pacific Ridge. The results reveal important details about the geological features of the Eastern Pacific Ridge. This is a major underwater mountain range that stretches across the Pacific Ocean. The Eastern Pacific Ridge is famous for its immensity and its role in creating the new solar crust. This ridge is part of the global mid-ocean ridge system that surrounds the Earth. It's made up of huge underwater mountains, uplift about feet from the seafloor. The ridge is the boundary between the tectonic plates, magma and daemon. Rise to form new skills. This process not only generates new geological features, it also plays a key role in the overall dynamics of the solar floor. From the Gulf of California to the southern tip of the Pacific Ocean stretches for miles. It is an important dividing line between the Pacific Plate and the North American Cocos Plate and the Antarctic Plate. The ridge is characterized by continuous volcanic activity. This helps to form new oceanic crust. As the plates separate, magma rises through cracks and solidifies, gradually forming a ridge. Ridges are underwater mountains. They're called seamounts. It is one of the highest mountains in the world. These structures are not just geological wonders. They also play a crucial role in the marine ecosystem. Hot nocturnal vents on ridges support unique biomes. They thrive in extreme conditions. These vents release mineral-rich fluids, provides an important source of nutrients for an otherwise nutrient-deficient environment. The Eastern Pacific Ridge is also a focus of scientific research. Because of its volcanic and tectonic activity, it helps to understand the driving processes of plate tectonics and crustal formation. Understanding these dynamics helps scientists predict seismic activity and study ocean processes. Understanding the relationship between the East Pacific Ridge and the Mariana Trench tribute requires extensive investigation. Scientists speculate that the formation of trenches may be related to geological processes in sea ridges. The trench is located in the western part of the Pacific Plate. The Eastern Pacific Ridge is on the other side. This arrangement suggests a possible connection between ridge activity and trench formation. The hypothesis is that the process occurs on the ocean floor. For example, magmatic activity and the formation of the core crust may contribute to the formation of deep trenches like the Mariana Trench. The development of sonar technology has been crucial to exploring and mapping these underwater features. Sonar is an acronym for some navigation and ranging. It uses sound waves to detect objects and map underwater topography. This technique allows scientists to create a detailed map of the sun's bottom. Both the East Pacific Ridge and Mali, the complex topography of the Mariana Trench. Sonar data allows us to understand the depth and shape of these terrains, deepened our understanding of their formation and evolution. Another major advance in the field of exploration came from the development of this detector mat during the Cold War. It was originally designed by the US Navy, used to detect Soviet submarines by identifying metal casings. But MAD technology accidentally discovered an anomalous magnetic pattern along the coast of Haiji in the eastern Pacific. These patterns appear as alternating stripes on the seafloor. They're like zebra stripes. The streaks are the result of Earth's magnetic field reversing every 300,000 years. As magma cools and solidifies on the ridge. And he recorded these stimulus reversals, and that formed the historical record of the Earth's magnetic field. The discovery of these magnetic stripe lines provides valuable information for the geological processes in Yangzhong. Scientists have learned that magma rising from the depths of the Earth formed the solar ridges. When he erupted from between the tectonic plates, this process pushes up the sun bottom. New ridges are formed and recorded the Earth's magnetic field. Before the magma solidified, altering the arrangement of magnetic forces in magma can help form alternating solar bottom stripes. This finding confirms the theory of seafloor expansion and the continuous formation of new crust. On the solar ridge, the older crust is pushed away. The significance of these magnetic stripes goes far beyond their visual appearance. They are a natural record of the reversal of Earth's magnetic field. Help scientists determine the rate at which plates are separating. For example, the Atlantic and Pacific Oceans are expanding from their respective ridges at a rate of more than 2 inches per year. The patterns recorded by the magnetic stripe provide key data for understanding tectonic plate motion and the formation of oceanic features. Exploration of the eastern Pacific Ridge also revealed hot nocturnal vents. Led by Dudley Foster, the next team of scientists is hopeful of exploring deep ocean ridges. At first, their search made no major discoveries, but perseverance allowed them to stumble upon something new. They discovered a towering rock spire emitting toxic heat. The surrounding waters sparkled with unusually warm temperatures, bubbles. The measured temperature is close to Fahrenheit. It's hotter than typical deep-sea water. The discovery of the Rui event was groundbreaking, and there are several reasons for that. First, he provided evidence that the heat of magma reached the ocean floor. These vents suggest that magma is actively pushing the new Earth on the Pacific Ridge. These vents create zones of warm water in the depths of an otherwise cold ocean. This highlights ongoing geological processes. The discovery has helped to understand the broader geology of the Mariana Trench, because it shows the direct effect of magma-driven processes on the seafloor. Off-road vents play a key role in understanding sheep shell formation. They confirmed that new crust is constantly being formed by magma rising on the solar ridges. As the new magma solidifies, it will push apart the crust, forming secondary strips that record the reversal of the Earth's magnetic field. This process shows how sheep shells form and move along the ridge to other areas, including the Mariana Trench. The discovery of these vents deepened our understanding of sheep shell formation, understanding its relationship to other geological features. The mystery of crustal movement and its relationship to the Mariana Trench has been a major research topic. New seafloor is constantly forming on the seafloor. This raises questions about the fate of the old crust. If new crust forms on the ocean floor, Earth's surface should not expand significantly to maintain balance. the old crust must have disappeared somewhere. Scientists believe that the Mariana Trench is where old crust may have been consumed. It's based on observations of patterns of crustal formation and displacement. It is believed that the old crust was pulled back to Earth at the trench. This idea of subduction zones explains where the old crust is. Subduction occurs in deep trenches like the Mariana Trench. The top of the trench is pulled back into Demon. This process balances the formation of new crust squeezed into the ocean. The Mariana Trench is the deepest ocean trench in the world. It is a key area for studying subduction zones and understanding the dynamic properties of the Earth's crust. Subduction zones are crucial to explaining how the Earth's surface is constantly changing and evolving. It gives us insight into the ongoing processes that shape our planet. Exploration and mapping of the Mariana Trench and Eastern Pacific Ridge driven major advances in geological science. From word pattern, thermal industry, data from vents and sonar techniques have greatly advanced our understanding of the tectonic process and the formation of the male sheath. Ongoing research will continue to explore the complexity and movement of the Earth's crust. The findings related to these deep-sea features contribute to a better understanding of seismic activity, plate tectonics, and the dynamic properties of the Earth's surface. Future explorations will build on previous discoveries, utilize advanced technologies to study and understand the deep-sea environment. Innovative and exploratory tools and technologies will further reveal the mysteries of the ocean floor. The scientific community remains committed to studying the dynamic processes that shape our planet. The point is to uncover the complexity of Earth's geological and oceanic features. With the continuous development of technology, the new findings will further strengthen the complex process that drives the formation and movement of the Earth's crust. What are your thoughts on the mysterious phenomenon surrounding the Mariana Trench? Please leave a message in the comment area. Thanks for watching. Don't forget to click like and subscribe to our channel. Click on the next video displayed on the screen. Would you like it?